Hi, my name is Pallie Thompson. I'm a teacher at Hines Parkview School in New Orleans. Today, you're going to see a video of third graders doing a math lesson using Eureka Squared in Module 4, which is about area and measurement. In this lesson, students have to draw rows and columns to complete a rectangular array and determine the area, even if some of the squares are missing. So they'll have an incomplete array, and they need to remember and realize that they only need one complete row or one complete column to be able to determine the area of the rectangle. In previous lessons, we have used manipulatives to tile shapes, and realizing that the tiles have to be even, no gaps between them, nothing stacked on top, and being able to relate those tiles to a side length. At the end of this lesson, also students are really using the terms square units or square feet or square inches, whatever the measurement is, to be able to understand that area takes up space. It's not a line. One of the things I'm very passionate about as an educator is literacy. Being able to read at a fluent level, at your grade level, is essential in all subjects now. Math is no longer about just the numbers. It's about being able to understand the problem, being able to understand what the question is asking, being able to understand how to communicate your answer in a way that makes sense. In our classroom, we work in groups, so there's lots of group work that you'll see, and there's also lots of team talking. Students learn from each other in my classroom, as well as from the teacher and from their own experience. So today we're going to be talking more about finding area and how you can use a grid to find your area. So yesterday, think back, yesterday we thought back to, if you have a grid right here, it's real easy to find the area. If I draw this shape, what are some ways we could find the area of that shape, Elijah?
We could use squares.
How could we use the squares?
We could put them in areas where it looks like a square would be.
Okay, are there squares on the paper?
No.
Yes. Okay, Carrie, keep talking about this. How could we find the area?
We could find the area by looking at it as an array and seeing how many squares there are going this way and this way.
Okay, so we can pretend like this is an array. Do we need to pretend that it's an array, or is it actually an array?
It's
It's actually an array. So we can count the rows and count the columns to find the area. If we don't know how to do that, can we just count the squares?
Yes.
But we're big third graders, so do we need to count every single square?
No.
Why not? Rami, why is that a bad idea?
Because if you count the squares, it's going to take you long.
It'll take you too long, and you're gonna end up making a mistake, right? This is a lot of squares. If I lose count somewhere, I'm gonna end up making a mistake. All right, so if I have this shape, y'all can see the array in there, right?
Yes.
But what happens when I do this? When I cover up some of the squares? Is the array still there?
No.
No?
Yes.
Talk with your partner. Is the array still there?
To make them a whole. That made
and we could still see it. The race still there.
10 seconds.
And
still there?
Yes.
It is?
Yes.
Zayden, what did y'all decide?
It is still there because we can still see the squares, a bit of the squares, so we can count the rest of the squares, and then it makes a number.
Okay, so how could we figure out the area of this rectangle even though we can't count all the squares? Allie?
We can put the two triangles together and make a hole.
Well, I want to know the area of this whole shape. Not what's not covered, the area of the whole shape. Kalina, how can I figure that out?
We could measure it.
Okay. I don't have a ruler. What could I use to measure it?
You could use the blocks on your desk.
Could I use the blocks on the paper?
Yeah.
Okay. And how would I count that?
You would count it 1, 2, 3, 4, 5, 6.
So this side is how long?
6
6 squares,
squares.
right?
Yeah.
We don't know if it's centimeters, but it's just 6 squares. And what about this side?
So you can count the blocks.
All right.
on that side.
Count them, Elia.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Ooh, 11. That's bigger than we usually multiply. So we have 11 squares. So even though I can't count every square, because I can't see them all, Carrie, how can I find the area right now?
Because you also know that when you're going this way, they both have the same thing. And when you're going this way, they both have the same thing. So the way you could do that is by, so the way you could do that is by,
Is there an equation we can come up with? Okay, what is it?
6 squares times 11 squares equals area.
That equals the area. Because when we're finding an area, it's the same as finding an array, right?
Yeah.
So what is 6 times 11?
66.
66 squares, right? That's our area. All right, when you get back to your seats, you're gonna turn to workbook page 7, right here. And I want you to look at these 2 rectangles. And it says, each square is 1 centimeter. You're gonna circle your units. Use a straight edge to complete each array, then label the side lengths and find the area of the rectangle. So watch this. You're gonna take your ruler, we'll pass those out, and you're gonna finish the array. So you're gonna bless you.
Thank you.
Okay, so the array is 5 centimeters. 5 centimeters times 6 centimeters equals 30.
30 what?
30 squares.
Not square, square what? Centimeters, exactly. All right, and what do we do? Okay, you do 1 through 4, so keep going.
I'm waiting for the rest to finish.
Okay, we'll go forward. All right. All right, what do you have to do first? Your ruler, so you go. Make it nice and straight.
Yeah, 30. If you look on the clock,
Okay, that's a good way to do it. All right, now what's your equation for this one?
So my equation
Okay, so label each side.
5 and 6. So in each row is 9. So then if I combine those two together, 6 centimeters times 5 centimeters.
Yes.
Then that would probably equal
Yes.
then 6 centimeters times 5 centimeters would equal 30 square centimeters.
I'll check in just a second. All right. All right, so what did you need to know about that rectangle to help find the area?
We needed to know the side length.
The side length. Was that what was helpful, Tristan? What was the side length? How did you find the side length? Kiani, how did you find the side length?
I counted the blocks, and then I counted the side. That's how I got it.
You counted across the top and you counted down the side. Raise your hand if you did that. You counted across the top and you counted down the side. Okay, put your hands down. So answer me this question. Did you need to draw the lines? Raise your hand if you can answer that for me. Did you need to draw the lines? Carrie? Why not?
Because knowing that you don't need to draw the lines is because you already know. You can imagine that they're there.
You can imagine that they're there. All right, let's look at number 5. It looks like they've drawn out a room in someone's house. Read. So the video ends and students continue working on practice problems with their partners, and we check our work. Then we go on to the exit ticket. The exit ticket gets right at the key question of what information do you need from an array to find the area of a related rectangle. So the question in the exit ticket says, what is the area of a tiled space that's partially covered by a rug? So students have to be able to realize the information they need from an array is that they need the side lengths of the array, which is the side lengths of the tiled floor. So students had to write a multiplication equation that said side length times side lengths equals the area. And most students were able to do that, so I know my objectives were met. If I were to do anything differently in this lesson, I would add 2 more examples at the very beginning of the lesson to help students understand where we were going further in this lesson, knowing that you need to find the area of a shape that's partially covered by something else. In the greater scheme of things in this unit, we continue in further lessons to put larger rectangles together, to add areas of different shapes. We also take larger shapes and break them apart and talk about the areas of 2 shapes together. This all goes back to multiplication problems that we've done in previous modules that talk about the commutative and associative property, the distributive property as well. So this unit fits right into the theme of 3rd grade, which is multiplication and division.